Okay, so in this problem, we have a car that has a mass of 1750. It drives in a circle at a constant speed of 15 meters per second. Static friction between the tires and the car is what prevents the car from sliding sideways. Alright, our first task. Determine the coefficient of static friction if the sharpest turn the car can make is 22 meters. What that means is that this car cannot turn any shorter than 22 meters. So it essentially has a turning radius of 22 meters, if you're familiar with that term. Alright, so our first thing is to realize that our centripetal force must be our net force, because the net force has to be acting towards the center in order to maintain this trajectory of this car moving in a circle. We're told that the static friction is what keeps it from sliding away. If that's true, then the static friction must be the force that's keeping this car in a circle. So, the centripetal force must be equal to the force from static friction. Alright, so we draw a free body diagram and we see that the normal force going up is going to be equal to mg, because there's no other forces acting here in the y direction. Okay, our centripetal force, as we previously determined, is equal to our static friction. Static friction, what we remember from our forces, from our formulas, is that the coefficient of static friction times the normal force will give you static friction. Normal force, as what we determined from our free body diagram, normal force equals mg. Okay, so centripetal force is equal to ma. That is our Newton's second law. F equals ma. Centripetal acceleration, something unique to centripetal motion, is mv squared over r. mv squared over r. Alright, that allows us to set up this equation. mv squared over r is equal to mu s mg. Then all we have to do is solve for mu s. Mu s is equal to v squared over rg. Alright, our next task is to determine what the centripetal force is. Well, we know our formula, centripetal force is equal to ma, so this would be what a is equal to, v squared over r. So we plug in our numbers, we have our mass, we have our velocity, and we have our r. And that's it.